Hello, what's up? It's Steve here in Black Labs. So 4 years ago, I designed and began constructing a jet engine, which was intended to be self-sustained and wasn't completed due to the lack of some resources. Earlier this year, I decided to take on the project. So this video, I'm going to share my ideas with you on how this mod works, so you can take on the game. Why it was the main content of this video.
So here we have the CJ2 Pro, which is a successor to two previous jet engines, one of which was just for fun, and we have this one here, which wasn't completed due to the complexity of machining such a small jet engine. And if you haven't guessed it yet, the C stands for kerosene, the J for jet engine, and 2 Pro just for the fact that it is an upgrade to my second jet engine design. I had to do a little modification from how standard axial jet engines work, so let's dive into drawing board. Here we have a sketch from 4 years back. As you can see, it's probably messed up, but it still serves a purpose. To begin, I would love to note that there are two main components that makes this project incomplete. First, we have the compressor turbine at the front, which sucks in air. And secondly, we have the turbocharger at the back, which drives the compressor at the front. They are both turbines but of different sizes and functions. About how this jet engine works, the first system is the compression system, which comprises of an air channel. Here we have a sample. A compressor turbine, as I earlier said, I haven't made, and the body covering. These three components work together to perform the action of taking in and compressing air as follows. The compressor is simply a turbine and somehow looks like this, which sucks in air. This air then flows down through the walls of the air channel, which with the body covering forms a narrowing path, hence compressing the air. So in my design, instead of using multiple turbines in the compression system, I use a single turbine for experimental purposes. Okay, the compressed air. Upon getting to the combustion chamber walls, we have the stator vane, which is simply a static turbine, that is a turbine which doesn't move. The main purpose of the stator vane is due to the inclined nature of the air from the compressor, which then flows through the blades of the stator, straightens, then moves down through the walls of the combustion chamber alongside the body covering and into the combustion chamber through these holes. These holes help to regulate the pressure of the air getting into the combustion chamber and also to prevent the quenching of the flame in the combustion chamber. This design is simply to insulate the heat from the combustion chamber from getting to the walls of the jet engine. Okay, the heat is due to the combustion of fuel provided by the fuel delivery tubes. The fuel delivery tubes are then interconnected via a fuel delivery ring. And from the sketch, here we have the fuel delivery ring, the fuel delivery tube, and the evaporating tube, as you can see out. Here we have something similar. And again, here we have the fuel delivery tubes, the fuel delivery ring, and the evaporating tubes. Either liquid or gaseous, or maybe just both fuels could be used in this jet engine design. Hence, the evaporating tube pumps in, which is basically a hot tube which converts liquid fuel into vapor once it drops from the fuel delivery tube onto it. This increases the surface area for combustion between the oxygen-rich air and the fuel, which could be ignited via a spark plug or a match, causing the mixture to suddenly explode or expand, rushing out through the nozzle as exhaust. Upon leaving the nozzle, we have another stator. As I earlier said, a stator is simply a type of turbine, but that which doesn't move. This shaft spins at the center and carries the turbocharger. The main function of the stator is to redirect the exhaust at a particular angle to the blades of the turbocharger. The pressure from the exhaust is converted into kinetic energy to drive this shaft, which is connected to the compressor and the turbocharger. The turbocharger is designed such that when exhaust passes through it, it works like a wind turbine, rotating the compressor in a direction that favors air to be sucked in. And if the kinetic energy generated from the exhaust is capable of driving the compressor such that it sucks in an appropriate amount of air necessary for combustion and the cycle continues, then we have a self-sustained jet engine. As for now, all this is theory, and I would love to probably take on the project and make it real while sharing my ideas with you, but I'm quite busy with academics, and immediately I'm done with it, I will take on. See you there.